Hi students, in this section you're going to be learning about solving equations using multiplication and division. So remember, when we're solving and working with equations, you want to isolate the variable, meaning you want to get the variable all by itself on one side of the equal sign. So let's just get started in some examples here right away with solving equations using multiplication and division. Example number 1a, we have 8x equals 16. We want to isolate the variable x, meaning getting it all by itself here on the left side. So we need to get rid of that 8x. Well, what's the opposite of 8 times x? The opposite of multiplication is division. So I'm going to divide 8 to the left. Whatever you do to one side of the equation, you have to do to the other. So I'm going to divide 8 on the right side. So I have here x equals 16 over 8, and that is going to simplify to 2. So x equals 2, and that will be my answer. Now, when you're doing your bookwork, they sometimes might ask you to check. If they ever ask you to check your work, what they want you to do is they want you to substitute what you solved for back into the original equation to make sure the left side equals the right side. So check to make sure that 8 times 2 equals 16. It does equal 16, so we say 16 equals 16, and that checks itself out there. So that would be your check step if it asks you to do that. Let's look at b here. We have negative 7 times b equals negative 4. We're solving for b, so we need to isolate b, get it all by itself. So we're going to divide negative 7 to both the left and the right side. So on the left side, that negative 7 over negative 7 cancels, so you're left with b equals negative 4 over negative 7. Well, negative 4 over negative 7 just becomes 4 over 7. I cannot simplify 4 over 7 because 7 is a prime number, so b equals 4/7. That's going to be my answer. If they asked me to check this, I would go ahead and plug in 4/7 in for b. So I take negative 7, multiply 4/7. Negative 7 times 4 gives me negative 28 over 7, and that would simplify to negative 4. So that works itself out because negative 4 then equals negative 4. That would be my check step. Last example here, or last letter C, for example number 1, we're going to solve for x. We want to get x by itself, so we're going to divide negative 3 to both sides. So we're going to write x equals, notice negative 3 over negative 3 cancels. So I have 5 over negative 3, so that would stay 5 over negative 3. Leave it as the improper fraction, and that would be my value for x. Notice I show my steps by dividing the negative 3 to both sides, and then I'm circling my answer. I expect you to show your steps and circle your answer when you're solving this as well. If they wanted us to check this, I would plug this 5 over negative 3 back into the original. So I would do negative 3 here times 5 over negative 3 to get here negative 15 over negative 3, which simplifies to 5, which equals 5. So 5 equals 5. That checks itself out. Answer. So that's how I go about solving, working with multiplication. So now let's get into working with some division. Here with example 2, they want us to solve these equations, but look at these division problems. We have y over 4 equals 32, r over negative 5 equals 20, and 1/7 x equals 5/7. Well, let me write this y over 4, I'll rewrite this, equals 32. We want to isolate y, meaning getting it all by itself. To get rid of this 4 here on the denominator, what we do here is we multiply by the reciprocal, 4 over 1. That way it'll cancel on the left. The 4 will cancel on the left. But whatever I do to one side, remember I have to do to the other. So I'm going to multiply by 4 over 1 on the right. So here for a, I'm going to have y equals 32 times 4 is going to give me 128. Divided by 1, that's just 128. So y equals 128. I can check my work by plugging in 128 into the solution. So I would have 128 divided by 4. Does that give me 32? It sure does. So 32 equals 32. Answer. Y equals 128. That would be my answer. The steps above it show my work. This is just remember my check step. Next one we have here, R divided by -5 equals 20. We want to isolate R, meaning getting it all by itself. The opposite of division is multiplication, so we're going to divide -5 over 1 on the left. We're going to divide or multiply by -5 over 1 on the right. On the left, the -5's cancel, so I'm left with R equals 20 times -5 is going to give me -100 over 1, which is just -100. And that'll be my answer. To check this, I plug -100 in for R to make sure it works itself out here. So -100 divided by -5. Does that give me a positive 20? It sure does. So 20 equals 20. It checks itself out. The last example here is 1/7 x equals 5/7. So let me rewrite this. 1/7 x equals 5/7. We're working with two fractions here, but don't let that make you nervous or anything. So we're going to get rid of this 1/7 here on the left. So I'm going to multiply by the reciprocal, which is 7 over 1. Whatever I do to the one side, I have to do to the other. So multiply the right side by 7 over 1. On the left, 1/7 now cancel, so I have x equals 5/7 times 7 over 1. I can now multiply across if I want to get x equals 35 over 7, which simplifies to 5, or notice that I can cross cancel the 7's going to each other. Those become 1. And that would save us a step of simplifying to just get 5 times 1 is 5, 1 times 1 is 1, x equals 5. Answer. Again, I've run out of space to check it, but if they ask you to check it, you plug 5 back in for x to see that you get 5/7 on the left and right side, and you do. So that's the answer. So that is it for this section, and we'll do some practice problems from the book in class.